From today, we are going to discuss chapter 6. But before chapter 6, let me review the homework. So let me go to get into this engage. Section number 4. Already I posted today's homework number 10, yeah, from chapter 6, right? And let me go to the homework number 9. Any question from the homework? Yes. What do you want to do? The third part of number 8. Number 8. Okay, good. That is what I want to do. Let me copy and paste. Yeah. Yeah, it is a number 8. It is number 8. The question number 8, right? I want to try the old part. It is today's homework tonight from chapter 5 about the binomial distribution. But it didn't say anything. Yeah, it is the binomial, right? Let me see. Next Friday will be the March 10th. And not the Friday this week. Next week, Friday, we are going to take the second exam. Oh my God, yeah. Yeah, another 4 weeks. Yeah. So the next Friday, March 10th, we are going to take the second exam. And we are going to review on next Wednesday. But I might give you the small lecture on Wednesday because I'm not sure if I could. Today, we are going to start chapter 6, but I'm not sure if I could finish up chapter 6 before next Wednesday, right? But anyway, the next Wednesday will be the last lecture before the exam, right? So the second exam on next Friday will cover chapter 4 and 5 and 6, right? We completed chapter 4 and 5. So totally, you have the whole chapters, chapter 4, probability, 5, the discrete random variable, and chapter 6 is up to next Wednesday, right? Yeah. So as I did this weekend, it's a coming weekend, I will reopen all homeworks. It's after the first exam, right? So if you didn't complete, if you missed, then you can make them up, yeah, this weekend. But these weekdays, please focus on the chapter 6, right? Yeah. And then you can make them up from the weekend and next week, right? So this week, yeah, please focus on chapter 6, and you can prepare the exam from the weekend. You understand what I'm saying, right? And also, you can prepare a summary. It's another summary when you are preparing the second exam. And we are going to take the second exam on next Friday. Any questions? In the exam, I will give you a note. It is binomial problem. If I give you the note, it is a binomial problem, then you have to look for how many n, what is the probability. So any kind of binomial problem, we need how many n, what is the probability. Can you give me the n? You know, the n was the number of independent trials. How many n? 9, thank you. And also, can you see the probability of success? 15%. But always the probability must be as a decimals, 0.15. Okay, so let me try part A. No one has done. We need a probability. R is equal to 0. What was the R? The number of successes. In part A, we need a probability, no success. Then we use the probability function. Do you remember the probability function? C, N, R. probability of success with the power of, and also we needed the Q. To remember the other probability Q, how much will be the Q? 0.85. How did you get 0.85? 1 minus the P, right? It's a 0.85, 9 minus 0. Can you give me the C? Yeah, using your calculator, please give me the C. How much? Anybody? C? Anybody? 1, thank you. And how much will be with the power 0? Always 1. And how many powers in the last term? 9. So let me take 0.85 power 9. I have a 0.2316. 0.2316. I need the 3 decimal places. The answers must be 0.23 and 2. 3 decimals. Let me check the answers later. Okay? And the next one is at least 1. At least 1. Probability at least 1. What does it mean? At least 1. Let me ask you. You. Can you drink alcohol? Why not? You are not 21. Right? Can you? Yeah, we can drink alcohol. Yeah. As much as I want. Yeah. Why? Because we are 21 or older. If you want to drink alcohol, you must be at least 21. What does it mean? It's not only 21 years old and older. At least 1. What does it mean? 1 or more. Okay? Yeah. So when you have at least 1, please remember, please check if you can drink. 1 or more. Who are they? 1 or more. 1, 2, 3, up to what? 9. Number of successes. When I toss a coin 9 times, I have only up to 9 heads. Right? Yeah. And now here's at least 1. So from 1 to 9. In this case, we have to apply the formula 9 times. I don't want to do that. No. Any other idea? See, what would be possible smallest number of successes? 0. Please remember, when I toss a coin 9 times, what would be possible smallest number of heads? No heads. Always from 0 up to n. So this is a probability only from 1 to 9, except 0. But let me add additionally, add probability 0 and 1 to 9. How much do you expect the sum? Always 100%. Always. I told you. Yeah. Sum of all possible probabilities. Always 100%. We knew it. Now, I need only this one, except 0. Any idea? Subtract the probability of 0 minus probability 0, cancel out. The probability what we need, at least 1 or more up to 9, will be same as 1 minus the probability only at r equals 0. Does it make sense, right? Yeah. So now I can say. So 1 minus 0.5. So it must be 1 minus only 0. Remember.
Zero plus
What?
E 0 in parentheses plus
When I add probability of 0, then the left hand side will be 1, right? But I need it not this one, but only this one. So we just take subtract from 1. Can you remember what was the name of this before? Somebody said, complement. Complement. You know, when I make the Venn diagram, yeah, here. Let me delete. Let me write again. When I have a rectangle, all possible outcomes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Exactly, I can separate like this way. Then now the right hand side, there are at least 1. 1 or more. All possible probabilities, always 1, right? But we need the right hand side. Then subtract left 1 from 1 will be the right hand side. What is the name of this? Complement. The complement probability, right? But already we got it. How much was it? In part A, 0.232. 1 minus 0.232. How much will it be? 1 minus 0.232. Thank you. 0.768. Let me check them. Let me go to the question number 8. 0.232. 0.768. Do you have an idea? Okay. Now part C. Let me look at the part C. Part C, no more than 2. It's a no more than 2. Who are they? No more than 2. 0, 1, and 2? Or just 0 and 1? No more than 0, 1, and 2. So it must be probability 0, 1, and 2. No more than 2. So already we got the probability 0. Additionally, we need a probability 1 and we need a probability 2. So I have to apply the probability function twice more. At 1. 1, 1, and 1. 2, 2, 2, and 2. Right? Even you can use your small calculator, get the probability at 1, at 2. Already we got at 0, and then so on. But let me use Excel. You know, I love Excel. Excel is a good calculator in statistics. Oops, just a second. Right? So, how much was the probability of success? How much was the probability of success? 0.15, thank you. And the possible number of successes is up to 9. You know, in Excel, we have a function. We have statistical functions. And I need, did I use the Excel before? Yeah. It's make the distribution, right? Okay, good. Then now let me take the as a normal binomial the distribution and the number of successes. Oops, sorry. Then I have to get the number of trials 9, and the probability, and then false. Something wrong. Just a second. Let me try here again. The number of successes and number of trials 9, and probability of success and false. And let me take only 3 decimal places. Can you remember the probability 0.232 in part A? Right? Yeah, exactly. Yeah, we can get the probability in Excel and copy down. And definitely when I take the sum from 0 to 9, always 100%. And before at least 1, I got 1 minus this one, 0.768. You remember part B, at least 1? Let me take the sum from 1 to 9. How much do you expect? Would be same, 0.769. Why not, right? When you are using small calculator, you can take another probability at 1, another probability at 2. Part C, we need the sum, this one, and this one. Let me take the sum. Let me take the sum of these 3 probabilities. Let me check. I got the sum from 0 to 2, 0.859. Yeah, but you know, just twice more calculations. You can use the small calculator, but it's up to you. It's a homework, right? Why not? And probably last time I showed you the distribution, right? Did I? Did I show you the distribution? Like this? Right? Yeah, yeah. It's not from 1 to 10, but from select the data, 0 to 9. Yeah. It is the binomial distribution. Did I take the mean? I think I didn't, right? Yeah. Look at this. Who is this? Binomial probability distribution. It was a discrete random variable. How did we get the mean? We have to take the multiplication and then sum. Remember that, right? So let me take the sum. Let me take the mean. So let me delete. And now let me take the multiplication. Copy down. Then take the sum. 1.35. Does it make sense? The mean 1.35 center. This makes sense. Yeah. 1.35, 1.35 average in the middle, right? Well, let me apply 6 steps to get the standard deviation, right? So now it is the mean. And now let me take the difference, right? And copy down. And what? Square. And it will be the new step times the probability. Can you remember the 6 steps, right? And then take the sum. Finally, take the square root of it. Who is 1.071214? It is the standard deviation for the binomial distribution, right? So it was the mean, and it is the standard deviation. Yes, the mean and the standard deviation by 6 steps. Any question? And we can apply the 60 steps because the binomial distribution is discrete, random variable, right? Just a second. How many n? How many n was? 9. What was the probability of success? 0.15. Just for fun, can you take the multiplication? 9 times 0.15? Yeah, just for fun. Did you get 1.35? What was it? Oh my god. How is it magic? Isn't it? Right? We got 1.35. How? Take the multiplications, sum up. But now, simply just 9 times 0.15 will be the mean. Interesting. Very interesting. It will be the mean. But how about this? N times P times Q. 9 times 0.15. Yeah, already we did 1.35 times Q. How much was the Q? 85. Yeah, try it. It's just for fun. Just for fun. 9 times 0.15 times 0.85. Keep going. 1.1475. Simply just take square root of it. Simply just take square root of it. Who do you expect? Standard deviation. We don't need the 60 steps. Simply just take the multiplications n times p times q. Take the square root. It will be a standard deviation. Without 60 steps. What a magic. Right? Be careful. It is only true in the binomial distribution. Right? Any other discrete random variable, we must apply 60 steps. But it is true, that is true, only in the binomial. Okay, good. Let me switch 0.85. I didn't click enter yet. How much do you expect the mean? Then now the mean must be 9 times 0.85, please. Simply, I expect the mean will be 9 times 0.85. How much will be? Say again? 7.65. Then when I click enter, what do you expect? On the graph, move to the right. Yes. How much was it? Inside, did you get 1.1475 square root? It was 1.071214. Why did it say? Because now it is a 0.85. It will be 0.15. Just to switch. So just I change 0.85. Then the average is moved to the right, but the standard deviation will be same. Let me plug 0.5. The probability is a 0.5. What do you expect the mean? Say again?
Middle.
4.5 in the middle, right? Good. And can you try 9 times 0.5 and 0.5, please? 9 times 0.5 and 0.5. You will have a 2.25 and square root of it. That will be 1.5. Standard deviation. And please look at the histogram. Exactly symmetric. Y is a 50, 50. Right? Yeah. So only in the binomial distribution, simply we can expect how much will be the mean, how much will be the standard deviation. Okay. Yeah. Let me finish chapter 5. If you didn't do the homework, yeah, please complete. It's a tonight, number 9, but already I posted the number 10. Okay, let me go to chapter 6. Chapter 6, before I introduce you, in chapter 5, we discussed discrete random variable. And I told you, chapter 6, we are going to discuss continuous random variable. Do you remember that? Right? But please look at the title, chapter 6. We are going to discuss the normal curve. It will be normal distribution. You know, before in chapter 5, we had a binomial distribution. Because it was, the binomial distribution is one of the common discrete random variable. Now the normal distribution, it is the most common continuous random variable. So in chapter 6, we are going to discuss the normal distribution. Please look at the picture. The normal distribution can be defined from negative infinity up to the positive infinity continuously. And the height of the bell curve, that is the probabilities. So the height will be the probabilities, continuously, countless, uncountable. Okay? So it is the bell shape, the normal distribution, and exactly symmetric, right? So here is the properties of the normal distribution. The first of all, bell shape, and the highest probability in the middle. See, in the middle, here is a Greek letter, it's a mu. It is a mu, it's not u, it's a mu, mu. That is for the mean. And here is a sigma, is another Greek letter, sigma, for the standard deviation. You know, before, in the binomial distribution, we found how much was the mean and the standard deviation. Just before, we take the multiplication n times p, square root of n times p times q. We found the mean and the standard deviation, right? But in the normal distribution, we don't have to. Always the mean and the standard deviation will be given. Before, in the binomial distribution, we have to figure out how many n, what was the n, and what is the probability of success, right? Now, in the normal distribution, we have to look for what will be the mean and what will be the standard deviation. They will be given. They will be. So simply, we just focus on the probabilities. How can we get the probability, right? So the probabilities, yeah, we have continuous, countless, uncountable probabilities. But it is the same thing. Please look at the last one. Even though we have countless probabilities from negative infinity up to the positive infinity, but we just sum up. We just sum up uncountable probabilities, but it just up to 100%. So when I take the area, from the negative infinite up to the positive infinite under the curve, it must be 100%. Only up to 1. Remember, it's the same thing. Any kind of random variable, the sum will be just 1. So it is the normal distribution, and today I will introduce you a special case. It's a name, the standard normal distribution. It is a special case. Only when mean equals 0 and the standard deviation equal to 1. So because of that, in the middle, there is a 1, there is a 0. And -1, +1, -3, and +3. You know, theoretically, the normal distribution can be defined from negative infinite up to the positive infinite. But the standard normal distribution, the mean equals 0, and the standard deviation is equal to 1. Between -3 and +3, there is the almost 100%, 99.7%. So initially, I can give you the plus and minus 4. From -4 up to +4, there is a really almost 100%. What does it mean? Less than -4, nothing. It's almost nothing probability. How about the above? It's bigger than +4. It's nothing too, right? It's almost 100%, almost the whole probability between -4 and +4 on the standard normal distribution. So we are going to find the area under the curve, under the standard normal curve. That means we are going to get the probability. We are going to look for a probability. Left-hand side of the z-score, -1.00. So let me make the bell curve again for the standard normal distribution. And can you see the letter Z here? You know, the Z is the letter for the standard normal distribution. That's mean equals 0. And I need the left-hand side of, that's -1.00. Any values negative must be in the left-hand side because we plug the 0 in the middle. It's all negative values, all positive values. So we need the probability less than -1.080. In chapter 6, for the normal distribution, we don't have to find the mean and the standard deviation because they will be given. Even the standard normal distribution, mean was given, 0. Standard deviation was given, 1, right? So we don't care how much will be the mean and how much will be the standard deviation. But we need a probability. How did you get the probability in the binomial distribution? We use the formula. C n comma r times p to the r q n minus r. We use the probability formula. Yes, standard normal distribution has another probability formula. Let me show you. Let me introduce you. The probability function will be 1 over square root of 2 pi e to the negative x squared over 2. Don't copy. Don't copy. Erase it. Erase it. Yeah, we are not going to use it. I just simply introduced you. Erase it, right? Yeah. No. But using the function, we can make the bell curve. And now we need the area under the bell curve, under the function, right? Anybody who took the calculus? Calculus? Thank you. Remember, how did we get the area under any function in calculus? Have ever seen this kind of notation? Like this? Dx? Have you ever heard the integral? Integral? Good, right? Yeah, that is integral. Have you heard integral? No? Ignore it. We are not going to use the function because many of you didn't take calculus. Even today is the first day I ever heard the integral. Oh my God, you don't know. I don't know what is integral. Don't worry about it. Somebody did. On the next page, somebody suggested the Z table. We just pick a probability from the Z table. Huh. Even we don't have to. We don't have to plug what is the n, what, no. Just to pick one, right?
Okay.
Yeah, good. It looks good, right? How much was the Z-score? Negative 1.00. Negative. Say, or positive. Don't worry. We have another table. We have a second table. Ta-da! Yeah. What was the Z-score? Negative 1.0. We had two decimal places, right? Where is the second decimal place? Up here. Negative 1.0 and 0. There is a probability 0.15. It is a probability. Left hand side. Left hand side.
We can have this table in class.
Yes.
Okay.
You have to bring it. Yeah. Did you print out the table? Why not? Please go to the lecture notes. Please must print out the table.
Can that be on a separate paper then?
It's up to you. It's up to you. It doesn't matter. Right? If you need more space, one side, on the back. Right? Yeah. Please, if you didn't print out the lecture note, because it is the 2 pages in the lecture note, please and must print out and bring it every day. Every day from today, we are going to use the Z table. Okay? It is the answer. No calculation, no calculator. 0.1587. It will be the probability. Where it is? Left hand side. How much did I say? No. That is a negative 1.00 is a Z-score. And we found a probability 0.1857.
I think it's 1587.
1587. Thank you. That will be a probability. Remember, probability must be between 0 and 1. Positive. Right? Oh, here's another one. Left hand side of 1.18. Then let me go to the first page. Positive 1.1. Positive 1.1 and 8. Right? Left hand side 1.18. 0.8810. So when I make another picture, I need the probability left hand side of 1.18. How much was it? 0.8810. We don't have to take the mean, we don't have to take the standard deviation, only we need the probability. Even no calculation. Just to print out and bring the Z table, we just pick a probability from the Z table. It is much easier than binomial distribution, isn't it? Right? Yeah. You like it? I love it.
This always works.
Always works, yes. Always. Yes. Let me give you another example. Now here's another example. Again, the Z-scores, right? The standard normal distribution is mean equals 0. And now two Z-scores, 1.00, 2.10. But now I need the area between the two scores. Okay, let me look for the probability. Yeah, let me look for two probabilities at positive 1.00 and the other one is a positive 2.10. Let me go to the positive Z-score table. Who was the first one? 1.00, 1.0 and 0. Yeah, can you take 0.8413? Yeah, please make a note. 0.8413. Yeah, please give me later, right? And how much was the other one? The other z-score? 2.10. 2.1 and 0. Yeah, please take it. 0.90.
2.1.
Yeah, you told me, yeah, 2.1 and 0. Yeah. 9821. 0.9821. Right? Yeah. Okay, so let me go to, yeah, you know, I have a short memory. So please give me the probability at 1.00. 0.84, huh? 13. Where will be? To the left. And what was the second one? 9821. Where? To the left. You know, remember, the Z table gives us only the left probability, right? So left of 1.00, there is a probability of 0.8413, and the other one at 2.10, there is a 0.9821. But I need a probability in the middle. Thank you. How? Always you have to take bigger one minus the smaller one. Do you know why? Because we are going to find the probability. Probability must be always you must take bigger one minus the smaller one to make the positive. So the probability between here must be 0.9821 minus 0.8413. So the difference will be 0.140 thank you. This makes sense, right? Any question? Can you understand the idea, right? Yeah. Why don't you look at the next one? We have another standard normal distribution is mean equals 0. And now we have 0.94. But we need a right-hand side. Before take the probability from the Z table, let me ask you. How much do you expect the probability is bigger than 0? It's right-hand side. Just right-hand side. It's bigger than 0. Huh? How did you get 50%?
Use the view divide 1 by 2. So the entire area of the curve is 1.
Entire area was 100%. And we knew the normal distribution is exactly symmetrical, right? I just asked you how much would be the half? 50%, right? Okay, now, before, take the probability here, but do you expect here is a less than 50% or bigger than 50%? Less than 50%, good. Let me look for the probability at 0.9 and 4. 0.9 and 4. 0.9, 0.9 and 4. 0.82, 64. 0.82, 64. 0.82, 64. 0.82, 64. Just a second. We expected the probability will be less than 50%. But we found 0.8264. What's wrong?
That only goes to the left.
Thank you. Where is the probability? Always to the left. Only here. But I need to the right. Any idea? Subtract from 1. Why? How much was the whole area? 1. We got left. We need right. What was the name of the probability? Complement event again. Thank you. So the right-hand side, it must be 1 minus 0.8264. 1736. Even though the z table gave us only the left-hand side of probability, but we can take the probability between even to the right. Good, right? Any question? Here's the quiz number 10. As many of you, quiz number 10. Many of you don't have the z table. So why don't you copy? Why don't you copy the 3 parts and please put some space somewhere? Okay. So it's the first one. We need the probability. The z is less than 1.23, and part B bigger than 2.57. Now please put some space. I will show you the z table, right? And C is between 2.71 and 3.01. And I can show you the, here it is on the whiteboard. Yes, here. Last thing? First thing. How do you think? The first one. The first one is less than. Where it is? Less than. To the left. So we have a standard normal distribution, mean equals 0, 1.23 to the left, less than. So I can take a probability 1.2 and 3, 0.8907. Do I have to do 1 minus? No, yeah, that is the left-hand side, right? So 1.2 and 3. 0.8907. But how about the part B? We need a probability 2.57 bigger. Where is the bigger? To the right. So you have to take a probability from the Z table and then 1 minus. 1 minus. You need the 1 minus. Strongly isolated to make the picture. Yeah, it is takes time but easier. It makes visualize is much makes it easier. But maybe later you can get the probability without anything. You are smart. What did you know, Alexander? Chris Mendoza?
Yeah.
Everybody got yours, man?
Oh, yeah.
I have a quiz without a name. Yeah, here's the quiz. Yeah, please place your quiz here.